The concept of economic efficiency judges the performance of any economic activity or any economic system by comparing it with that of others. There are many different criteria to judge the performance. These are economic efficiency, equity or social justice. All these judgments are required for well-being of the people. The idea behind economic efficiency is to make the people better off by proper allocation of resources in the society. The term better off is related to the idea of social welfare. In what follows, we will discuss equity and efficiency in the context of social welfare.
After studying this module, you shall be able to know the concept of social welfare function, learn the first and second welfare theorems, apply second welfare theorem, evaluate the efficiency and equity impact of the welfare theorems. Generally, it has been argued that perfectly competitive market is most ideal condition in which all the marginal conditions of Pareto optimality are satisfied. The first theorem of welfare economics postulates that a competitive market equilibrium will always be Pareto efficient. Diagrammatically, this can be seen by the fact that a competitive equilibrium occurs at a point where the ICs of the two individuals are tangent to each other. Pareto efficiency is defined as a situation where one individual cannot be made better off without making the other worse off. In other words, a point where the set of bundles preferred by individual A lies above his budget set and is also disjointed from the set of bundles preferred by B. The same holds true for individual B also. All these conditions are satisfied by a competitive equilibrium where A's set of preferred allocations do not intersect B's set, that is, ICs are tangent to each other and to the budget line, and there are no allocations that both the agents simultaneously prefer to the equilibrium allocation. Equilibrium is Pareto efficient. Let us now look at the implications of the first welfare theorem. According to the first welfare theorem, all market equilibriums are Pareto efficient. Although it is not based on any explicit assumption, there are some implicit assumptions. One important assumption is that economic agents, that is producers or consumers, care about their own consumption bundle and not about what others consume. However, if one economic agent cares about other economic agents' consumption bundle, then there is consumption externality, and it can be shown that in the presence of externalities, competitive market equilibrium is not Pareto efficient. Another important implicit assumption is that economic agents behave competitively. But if there are only two economic agents, then it is unlikely that they would take prices as given. Instead, they would use their market power to improve their own position. It can be shown that if there is a monopolist, then it would lead to inefficient allocation. There is also a second theorem of welfare economics. This postulates that when ICs are convex to their origin, every efficient allocation, that is every point on the contract curve for exchange, is a competitive equilibrium for some initial allocation of goods or distribution of input or income. When preferences are convex, then at Pareto efficient allocation, the bundles preferred by person A and the bundles preferred by person B are disjoint. Therefore, if both agents have convex preferences, then we can draw a straight line between two sets of preferred bundles that separates one from the other. The slope of this line gives us relative prices, and any endowment that puts both agents on this line lead to final market equilibrium, being the original Pareto efficient allocation. The significance of the second welfare theorem is that the issue of equity in distribution is logically separable from the issue of efficiency in allocation. This means that whatever the redistribution of income that society wants would lead to the exhaustion of all possible gains from exchange under perfect competition. Pareto optimality does not, therefore, imply equity. The second welfare theorem asserts that under certain conditions, every Pareto efficient allocation can be achieved as competitive equilibrium. The second welfare theorem implies that problem of distribution and efficiency can be separated. Whatever Pareto efficient allocation we want can be supported by market mechanism. It means that market mechanism is distributionary neutral. Whatever your criteria for a good or a just distribution of welfare, you can use competitive market to achieve it. Not all Pareto efficient points can be made market equilibrium when certain conditions are not met. One of these in non-convexity of preferences. If the preferences of both agents are convex, then the common agent will not intersect either indifference curve more than once, and everything will work out fine. In other words, if all agents have convex preferences, then there will always be a set of prices such that each Pareto efficient allocation is a market equilibrium for an appropriate assignment of endowments. Suppose out of the two individuals, A has non-convex preferences. Then a point like F can never be a competitive market equilibrium. In the diagram, F is Pareto efficient because A's indifference curve is tangent to B's indifference curve at F. But there is no set of prices at which both A and B will simultaneously want to consume at F. Suppose we dictate the price set as a slope of the common tangent at F. Then B would want the bundle F where his highest possible indifference curve is tangent to budget line. A, on the other hand, would want to consume the bundle G on the same budget line because he reaches his highest possible indifference curve at that point. Hence, the second welfare theorem implies that the problems of distribution and efficiency can be separated. Prices play two roles in a competitive market. First, allocative role, which indicates relative scarcity. Second, distributive role, which determines how much of different goods different people can purchase. According to the second welfare theorem, these two roles can be separated. That is, we can redistribute endowments of goods to determine how much wealth agents have and then use prices to indicate relative scarcity. In a competitive market, prices dictate the relative scarcity of a commodity. A convenient way to achieve efficient allocations is for each agent to face the true social cost of his or her actions and to make choices that reflect these costs. Hence, the decision to consume more or less of a good at the margin is dependent on the price, which measures how everyone else values this good on the margin. Such a process inherently leads to efficiency. Policy makers have often argued for intervening in pricing decisions on grounds of distributional equity, for example, reduce price of some goods so that poor people can afford it. But such intervention will interfere with the allocative role of prices and hence efficiency. Second welfare theorem says that Prices should be used to reflect scarcity. Lump sum transfers of wealth should be used to achieve distributional goals. In a competitive market, how much each person can consume depends on the value of his endowment. That is, it is determined by the value of the resources that a person has to sell. Thus, second welfare theorem says that in order to distribute goods differently, the state can transfer purchasing power of endowment. That is, the state can tax one consumer on the basis of value of his endowment and transfer the money to others. As long as taxes are based on the value of endowment and not on choices, there will be no loss of efficiency. Next is to see the role of the state. The state does not need to transfer the physical endowments themselves. All that is necessary is to transfer the purchasing power of the endowment. The state could tax one consumer on the basis of the value of his endowment and transfer this money to another. As long as the taxes are based on the value of the consumer's endowment of goods, there will be no loss of efficiency. It is only when taxes depend on the choices that a consumer makes that inefficiency result, since in this case, the taxes will affect the consumer's marginal choices. Tax on endowment will change the final outcome by changing people's behavior. But according to the first welfare theorem, any trade from any endowment will result in a Pareto efficient allocation as long as competitive markets are used. Thus, no matter how one redistributes endowments, the equilibrium allocation as determined by market forces will still be Pareto efficient. The problem with the above argument is that it might not always be easy to determine people's endowment of goods. It can be concluded that, according to the second welfare theorem, prices should not be used to redistribute income by offering some people lower prices than others. Lump sum transfers should be used to redistribute income, while prices should correctly reflect scarcity. In other words, it would be easy to have a lump sum tax on consumers, as all consumers could be taxed with blue eyes and redistribute the proceeds to consumers with brown eyes. As long as eye color can't be changed, there would be no loss in efficiency. Thus, society can use taxes, subsidies, and transfers to achieve what is considered to be a more equitable distribution of income. Hence, according to the second welfare theorem, lump sum taxation would be non-distortionary. Essentially, any Pareto efficient allocation could be achieved by such lump sum redistribution. These may discourage work, however, and show that there is usually a trade-off between efficiency and equity. Now we need to understand the meaning of fair and equitable allocation. An allocation is called fair if it is equitable and Pareto efficient. An allocation is called equitable if no agent prefers someone else's consumption bundle to his own bundle. If agent I prefers J's bundle of goods to his own, we say that I envies J. In other words, a social allocation is equitable if no one envies someone else's bundle to his own. Next, we need to understand the meaning of equal distribution and fairness. Our intuition might make us feel that if we have to divide m goods among n people, then a fair allocation might be an equal division of m goods among n people. An equal division will always be equitable because it is symmetric. Since each individual has the same bundle of goods, no one can envy the other individual's bundle. In other words, no individual prefers any other individual's bundle of goods to his own because they all have the same things. But an equal division will not necessarily be Pareto efficient. If people have different tastes and preferences, then everyone can be made better off by trading away from it. Arbitrary trading from an equal division might take us to a Pareto efficient allocation, but the Pareto efficient allocation might no longer be equitable. For example, suppose we have three people, A, B, and C. A and B have the same taste and preferences, while C has different taste. We start from equal division and suppose that A and C trade while B's bundle remains changed. The allocation post trading will have A and C better off and B equally well off as compared to equal division and hence will be Pareto efficient. But in the post trade equilibrium, B, who did not get the opportunity to trade, will envy A's bundle to his own because even though they originally had the same bundle, A got luckier in trading. Therefore, the post-trade allocation is Pareto efficient but is no longer fair since B envies A. Starting from an equal division, a competitive equilibrium leads to a fair allocation. This is demonstrated in the Edgeworth box diagram. Suppose we start from an equal division and using the competitive market reach an equilibrium. Thus, we move to a new allocation where each agent is choosing the best bundle of goods he can afford at the equilibrium price Px and Py. From first welfare theorem, we know that given certain conditions, all competitive equilibrium are Pareto efficient. Therefore, the new allocation is Pareto efficient. To determine whether any allocation is equitable or not, just look at the allocation that results if the two agents swap bundles. If this swapped allocation lies below each agent's indifference curve through the original allocation, then the original allocation is an equitable allocation. To prove that the new allocation is also equitable, we use in symbols px into wx to the power a plus py into wy to the power a is less than px into xb plus py into yb. This is equation 1, where xa, ya is less than xb and yb. But if A's own bundle is the best bundle that he can afford at price PXPY, then B's bundle being preferred over own means B's bundle must be unaffordable at PXPY for A, that is, initial endowment of A, which determines A's income at any prices. But in equation 1 is a contradiction because A and B started with the same initial endowment due to equal distribution. Thus, if A cannot afford B's bundle, B cannot afford it either. Hence, A cannot envy B's bundle in these circumstances. Diagrammatically, this can be seen from the Edgeworth box diagram. D is the initial distribution or equal division bundle from which we trade to the competitive equilibrium bundle or allocation E, where A's indifference curve is tangent to B's indifference curve, which means that E is Pareto efficient. To determine whether E is equitable, we swap the bundles of the two consumers. This results in the allocation F, which is a mirror image of E. But at F, both A and B are worse off because both are on lower ICs at F than at E. Hence, both would not want to move to a point like F by swapping bundles. Thus, the market mechanism will preserve certain kinds of equity. If the original allocation is equally divided, the final allocation must be fair. We may conclude that under perfect competition in all input and output markets, all the conditions for Pareto optimum are automatically satisfied. The first theorem of welfare economics postulates that equilibrium in competitive markets is Pareto optimal. The second theorem of welfare economics postulates that equity in distribution is logically separable from efficiency in allocation. The idea of fair allocation provides an alternative way to make distributional judgments. This idea emphasizes the idea of symmetric treatment. Even when the initial allocation is symmetric, arbitrary methods of trade will not necessarily produce a fair allocation. However, it turns out that the market mechanism will provide a fair allocation.
The module can be summarized in the following points. First, general equilibrium refers to the study of how the economy can adjust to have demand equal supply in all markets at the same time. Second, a Pareto efficient allocation is one in which there is no feasible reallocation of the goods that would make all consumers at least as well off and at least one consumer strictly better off. Third, the first theorem of welfare economics states that a competitive equilibrium is Pareto efficient. Fourth, the second theorem of welfare economics states that as long as preferences are convex, then every Pareto efficient allocation can be supported as a competitive equilibrium. Fifth, economists often use welfare functions of one sort or another to represent distributional judgments about allocations. Sixth, as long as the welfare function is increasing in each individual's utility, a welfare maximum will be Pareto efficient. Furthermore, every Pareto efficient allocation can be thought of maximizing some welfare function. Seventh, the idea of fair allocation provides an alternative way to make distributional judgments. This idea emphasizes the idea of symmetric treatment. Eighth, even when the initial allocation is symmetric, arbitrary methods of trade will not necessarily produce a fair allocation. However, it turns out that the market mechanism will provide a fair allocation. Ninth, according to second welfare theorem, lump sum taxation would be non-distortionary. Essentially, any Pareto efficient allocation could be achieved by such lump sum redistribution.